In the previous video, we saw that there was an association between the price of the placebo and whether or not a patient experienced pain reduction. But is that association statistically significant? Meaning, do we think that it would persist in the long run, or is it possible that it was just due to chance? So our question is the proportion of subjects who report pain reduction after taking a regular price pill significantly different from the proportion who report pain reduction after taking a discounted pill? So this is going to be phrased in terms of pi because we're thinking about what happens in the long run and we're talking about categorical data. The difference is that now we're comparing two groups. So basically we're asking, is pi for the regular price equal to pi for the discounted price? And we can write it like this. We can think of it in terms of pi for one group equaling pi for another group, but it's also really common to write the hypotheses in terms of a difference. So for example, we could write pi r for the regular minus pi d for the discounted, and then the null hypothesis would be that the difference between them is equal to 0. And this way of writing it may be preferred because it looks a little bit more similar to what we've done in one proportion z-test and one sample t-test, where we have a parameter equal to a number. If we wanted to describe this in words, we could just say, no difference between the long run proportions, or we could say in terms of the association that there is no association here, no association between the price of the placebo and pain reduction. So if there's no association, that means that knowing which placebo people got, whether they thought that it was regular price or discounted, doesn't tell you anything about whether their pain was reduced or not. In other words, the two probabilities would be the same. The alternative hypothesis here, if we look at how it's phrased, it asks whether it's significantly different. So this would be pi r minus pi d is not equal to 0. Or in terms of the association, there is an association, and I'm going to be lazy and not write it out, but there is an association between the price of the placebo and pain reduction. Okay, so the statistic that we got in the previous video was 0.244. That was the difference in proportions. Would this result be likely to occur by chance alone? So in this video, we're going to look at a simulation-based approach. So we're going to describe a simulation here, and probably the easiest way to do it is using cards. So we're going to have 82 cards to represent our subjects, and specifically we want to represent the response variable. So we're going to have 60 blue cards, and those are going to represent the people who had their pain reduced. And we have 22 green cards, and these are going to represent the people whose pain was not reduced. So we're looking at our sort of successes and failures in terms of the response variable. That's what we want to represent with our cards. Then we're going to shuffle the two groups together. Notice we're only looking at the response here. We're not labeling this based on whether it was a regular price or a discounted price. And the reason for that is because we're assuming in this case that price doesn't matter. So throughout the simulation, we assume that price doesn't matter. In other words, we assume that the null hypothesis is true. Then we're going to deal the cards into two piles of 41. That matches our sample sizes from the original study. And at this point, we're mimicking the random assignment. So when we say, could these results have happened by chance, we're really asking, could it just be because of random assignment that the groups didn't turn out perfectly even, right? That more people who were going to have their pain reduced anyway just happened to end up in the more expensive placebo group. Then we calculate the difference of proportions. This is the same statistic that we used to summarize the original sample, and we're going to use that to summarize each simulated sample. And that's going to give us a distribution of simulated samples, so we'll have something to compare to decide whether this would be likely by chance. And then we'll repeat many times to get the null distribution. So we're going to be using a new applet for this. We're using the Two Proportions Applet. So we'll let group A be the regular price. So we had 35 whose pain was reduced, and we had 6 whose pain was not reduced. Group B can be the discounted price. We had 25 whose pain was reduced and 16 whose pain was not reduced. And when we click Use Tables, we can see it updates the tables, and it also creates a segmented bar graph to display our data. I will say this is a little different from the mosaic plot that we saw before because the width of these bars will be the same even if your sample sizes are different. And you can see it's calculated the difference of proportions, 0.244, the same as what we got earlier. So when I look at my shuffle options, I can see I've got 60 blue cards and 22 green cards. When I click shuffle, it's going to randomly assign them into group A and group B, the regular price and the discounted price. And here it came out pretty close, 31 and 29 for the successes. We do it again, 33 and 27. So notice it's going to calculate the difference in proportions for each sample. So this one was 0.146. Do it again. This one's 0.049. We can also look at it in terms of the plot. So you can sort of see it doesn't come out perfectly even each time, right? Even would mean that there's no association, but sometimes you're going to get different values, and sometimes group A is going to be higher and sometimes group B is going to be higher. So I'm going to get up to 10,000. And looking at this image, I want to think about what each dot represents, right? These were simulated samples, and for each one, we were calculating the difference of proportions. So p hat for the regular price minus p hat for the discounted price. Also notice that this is centered at 0. The reason that it's centered at 0 is because we're assuming that there's no difference between the groups. In other words, we're assuming that the null hypothesis is true. So if the null hypothesis were true, how likely would we be to get a statistic like ours, 0.244 or more extreme? So we can find it there and count how many are further out. But remember, this was a two-sided test, so we want to have the other side too. We change this to beyond, and it's going to go the same distance on the other side and count those as well. So out of 10,000 simulations, 252 were as or more extreme as our sample results. So that's a p-value of 0.0252. So we found our sample value. P hat is 0.244. And we counted all the values that were as or more extreme on both sides and got a p-value of 0.0252. So what that's telling us is that if there were really no difference between the regular price and the discounted placebos, remember that's what we were assuming throughout the simulation, then results like ours would be, fairly unlikely. And specifically, the p-value quantifies that and tells us that it would happen about 2.5% of the time, about a 2.5% chance of getting results like ours or more extreme if the null hypothesis were true. So for a p-value like this, we would say that we have strong evidence, and we're always looking at evidence against the null and for the alternative. So in this case, it would be strong evidence to conclude that there is an association. Right? They're different. Knowing which price they saw is going to help you predict whether they had pain reduction or not. So there is an association between the price of the placebo, that was our explanatory variable, between price of the placebo and pain reduction. So one thing about wording here, when you say it in terms of the association, you're always going to talk about the association between the two variables, so between price and pain reduction. It would not be correct to say that there is an association between regular and discounted. So you can say that there is an association between the price of placebo and pain reduction, or you could say that there's a difference in the probability of pain reduction when you compare the regular price to the discounted price. However, it is not appropriate to say that there's an association between the regular price and the discounted price. That's sort of mixing together two different types of conclusions. So we have pretty strong evidence that the price of the placebo makes a difference, but this doesn't tell us how large the difference is. For that, we're going to need a confidence interval, and we're going to start with just a 2 SE interval because you can do that based on the simulation. So it's the same general formula, statistic plus or minus the multiplier times the standard error. So for the statistic, we're going to use the difference of proportions, 0.244, and this is a 2 SE interval, so we're just going to use 2 for the multiplier. For the standard error, we're going to get that from the simulation. So remember, every dot here is a statistic. So the standard deviation of a statistic is called the standard error. Specifically, this is the standard error of the difference of proportions, p hat r minus p hat d. So we'll fill in that value, 0.098. And we end up with a confidence interval that goes from 0.048 up to 0.440. So that's a pretty wide confidence interval when you think about how it can really only go from -1 to 1, so we don't have a super precise estimate here. There's more than one way that we can interpret this. One is pretty standard just based on the way we've done confidence intervals interpretations. One is pretty consistent with the way we've done confidence interval interpretations up to this point. We could say that we are 95% confident that, and then just think of the true parameter in context. So you could say that the true difference in the proportion who experience pain relief, so that's our parameter in this case. We've defined it as a difference. And because it matters which way we subtract, we want to make sure that we're explicit about that. So if you use this wording, you do want to say regular minus discounted, because of course the values, the positive and negative signs would be opposite if you were to subtract the other way. So we're 95% confident that the true difference in the proportion who experience pain reduction, regular minus discounted, is between these values. So it's somewhere between 0.048 and 0.440. Thinking about a difference of proportions in this way might be sort of difficult for people though, especially since the order of subtraction is important. And so another way that we could do it is to sort of use more causal language here. We could say we're 95% confident that believing the pill is discounted, and again, there's more than one way you can phrase this. To me, this one seems most natural, that believing the pill is discounted reduces the probability of improvement. And I'm saying probability, but that's just the same as the long run proportion. Reduces the probability of pain reduction by this amount, 0.048 to 0.440. So obviously that's causal language, but that's okay because we do have an experiment. So it's reasonable to say, because this is statistically significant, that it is the discount that had the effect on pain reduction.